It's time to learn about the scientific principles that we see in our everyday lives. Today's topic is trust in machines, which is also known as reliability. To trust something means to firmly believe in it and rely on it. Trust between people is formed through each other's thoughts and actions. Trust also applies to machines as well as people. In the context of machines, trust or reliability can also be defined as not malfunctioning. Similar to how humans have a lifespan, machines also have lifespans of their own. As a result, sometimes they can be fixed and used again, or sometimes they can't be fixed and need to be replaced. After a machine is made in a factory, its status is expressed in terms of its quality. However, when it's being used, its status is often described in terms of its reliability. Reliability can be defined as the probability that a given product will not malfunction for a defined period of time under given functioning and environmental conditions. The reason for conducting reliability tests when developing any product is because the developed products must work well without malfunctioning for certain periods of time. For example, a product with a target lifetime of 10 years is tested within a shorter period of time by simulating conditions similar to those that it would be subject to as if it had been used for 10 years. This is referred to as accelerated life testing. Tests conducted to determine product reliability start with setting goals. For example, the goal for a TV would be to ensure that it malfunctions less than once every 4 years, while a rail system might be designed to have a probability of malfunctioning of less than 1 in 100,000 per year. These are some examples of specific goals that are set for reliability testing. Accordingly, tests are designed for each part of the product, such as its various components, parts, modules, and systems. How does a malfunction happen? When the stress applied to a product exceeds the limits of its materials or parts, breakdowns or malfunctions can occur. Here, stress refers to the physical force applied to the product by mechanical, thermal, or chemical means. The limit of materials and parts is determined by their inherent strength. For example, if you compare this to a cup of water, the amount of water in the cup is the stress factor, and the size of the water cup is the limit factor. If the amount of water is too large or the size of the cup is too small, then the water will overflow. As such, the capacity to control these two factors well to prevent overflow can be referred to as reliability. In this way, reliable designs take both stress and limit factors into consideration. Products based on this approach then undergo accelerated life tests to prove their reliability, specifically by increasing the frequency or levels of stress they experience. There are certain causes or types of malfunctions that are more crucial to determining a product's reliability, so it is necessary to identify these factors and develop appropriate test equipment. The goal of reliability engineering is to reduce the initial malfunction rate and increase the lifespan of products. The general idea is to change the bathtub curve, which shows the rate of malfunction over time, into a smoother hockey stick shape. Increasing reliability is costly and time-consuming, so the way a product is optimized should account for the capacities and constraints of the producer. Therefore, reliability engineering involves aspects of both engineering and business management. The research team at the KIMM Department of Reliability Assessment, part of the Mechanical Systems Safety Research Division, is developing accurate methods for predicting the outcomes of reliability tests. It is also designing accelerated life tests used during product development to increase product reliability. With the recent development of various sensor and data analysis technologies, including artificial intelligence, it is now possible to monitor product performance in real time while it is in use. The research team is developing various technologies, such as a method for predicting malfunctions that evaluates a product's remaining lifespan in real time, and health management technologies. The team is also developing technologies that can virtually test a product's reliability. Korea Institute of Machinery and Materials is constantly striving to develop technologies to increase product safety and reliability.